This session is on arrays. Arrays is an object that contains collection of similar data type of elements. This means like if you want to work with a group of integers or a group of objects, let's say group of students, group of employees, then arrays can help you to do that. So most of the times you work with group of elements to provide some results. Basically, think of like if you want to work on some aggregate functions, like um, what is the student's grade, or how much students has passed in this school in this year. So you basically work with not a single student, you work with a group of students actually. Like this, most of the time we work not with a single element, we work with group of elements, and arrays is going to support that activity. This is the way to define an array or declare an array in Java. So when you declare integer, we say integer a. Here we say integer array a. The square bracket means it is an array. So here arrays is more like creating a just like creating an object. So how do you create an object? Like person p is equal to new person of. Similarly, arrays will be created like object, but there is a difference there. Instead of you put a new and then braces, here it will be going to be a square bracket. So here we say a is equal to new int of 3. This is actually creation or instantiation of the array. So what is going to happen here is a is a reference to the array, and it is going to point to a memory location. That memory location will have storage to store 3 integers there. And this array is going to happen in heap memory. So we can combine this declaration and instantiation in one step. Like you can put integer array a is equals new integer array of 3. That means it's going to reserve 3 memory locations, 3 integers memory locations for storing this array. Now now you have created the array, you have declared it, you have created the array, it has memory spaces available. If you want to put some values into the array, you can do like this. How do you do this? Like a is the reference of the array, and if you put a of 0, that corresponds to the first element in the array, a of 1 corresponds to the second element in the array, and a of 2 corresponds to the third element in the array. So you have reserved 3 spaces, and you are going to put some 3 values into it. If you don't put the values, it is going to be having 0 as the default value. So here we start with the 0 indexing. We have 3 elements, but the index will be starting from 0, 1 and 2. Another way to initialize, declare, create and initialize in one step is going to be like this. You don't need to put a new, it is automatically going to create if you put a curly braces and then you define the elements. So if I earlier itself I know like I have these 3 elements with which I'm going to create the array, all that you can put it together is integer array a is equals curly braces, the number of elements over there. So this is going to create an array which is going to have 3 memory locations. So we are talking about all this as a one-dimensional arrays. Later in this, we are going to talk about a multi-dimensional array, and in that we are going to talk about only 2-dimensional. So arrays is not limited to integer data type. As you know, you can create a float array, double array, string array, person array. So you can create arrays for objects also, not only for the data types. Okay, so the representation is going to be the same here. And one thing we have to notice, it's all fixed size. So here we say array, create 3 memory locations. That's what we are saying here. We cannot put a fourth value into it. Actually, it is going to give an exception called array index out of mode exception. So it's fixed size. You cannot increase the array after you have defined it actually. So at runtime you cannot increase the array or decrease the array. Those things are not possible with arrays. It is fixed size. Once allocated and created, it's going to be the same. So here is how the memory allocation happens with array. So in heap only these things gets created, not in your stack memory, just like your objects. So here is how it works. Like it is going to create 3 memory locations and put the values 10, 11, 12, and the starting location is maybe 2300. So the starting location will be holded by the reference a. So a knows how to reach out to this array. because it holds the initial location of that array. So when we say, and the important thing is arrays is going to get created in contiguous memory location, which means the next location it is going to get created. So the reason for that is you will be able to access in a faster way. So you don't need to if you want to get to the third element, we don't need to go to the first one and then go to the second one, then go to the third one. You don't need to parse like that. If I say I want a of 2, I will be able to directly reach out to the third element. So we'll see how we can do that. When you say I want a of 0, I want the first element, how the calculation happens is it takes the base address, that means the first location, and then it adds that the location. If it is a of 0, it is going to put 2300 plus 0 there. The star n is going to be number of memory locations needed for representing the integer. So current systems are like we are using 64-bit systems or 32-bit systems. So each memory location will be having 64 bits. So you know how much memory locations you need for representing an integer, which is just a 32-bit. So if you have a 32-bit machine or a 64-bit machine, you just need one memory location to represent an integer. But if you are using a 16-bit location, imagine when we used with a 16-bit, nowadays there's nothing like 16-bit, but when we use 16-bit systems, you may have needed two memory locations to represent one integer. In that case, the first location will be 2300, the second will be 2302, the third one will be 4, like that. So the memory locations will be different there. So so this basically not only applies to integer, like take a double, and then if you want to store a double in a 32-bit system, double needs 64-bit, so it will take two memory locations there. So in order to calculate directly which location I need to go, this will be helpful for you. So when you want to do, when a user says I want to get the second element in the array, he's saying a of 1, it takes the base address plus 1 into n. Here n is one memory location, so it's going to be 2301. Suppose if it is a double array and you are working on a 32-bit machine, you need two memory locations, it's going to be multiplied by 2, which means it's going to be 2302 there. So this is the easier and the faster way to reach out. The arrays are index based, and it is going to do a random access. It's not going to calculate. It's going to the first memory location and then go from there to second and all those things. It's just going to directly get to the point where you need to be. Data structure that helps to work with group of objects to achieve the desired result. That is what arrays represents. Let's move on to the next section, which is the multi-dimensional arrays. So how multi-dimensional arrays means, let's say anything more than one dimensional is called multi-dimensional arrays. So two-dimensional array is nothing but array of single dimensional array. Whereas single dimensional array is nothing but array of an integer, array of float, array of student, whatever it is. So two-dimensional means you are making an array of single dimensional arrays. And the same goes with three-dimensional. Three-dimensional array is nothing but array of two-dimensional arrays. Okay, let's see the syntax of two-dimensional arrays. So we have one-dimensional array, we had a one square bracket. Here we are going to have two square brackets. So here we say integer array A. How do we, there's a declaration, and the creation and instantiation will be the same way. But you can note it down here, like we say A is equal to new integer of 3, and then we left the next bracket as it is. So what does it mean here is, I say I want to create a two-dimensional array, and the two-dimensional array I want to give a length for that. How much length the two-dimensional array is going to be? I'm saying it is going to hold 3 one-dimensional arrays. That's what it says. But the next bracket says each of that one-dimensional arrays, how much it is going to hold, how much elements it is going to hold. If I'm not sure about it, I don't need to specify that. If you're sure, you can specify that. So this is a two-dimensional array which is going to hold 3 one-dimensional arrays that I need to specify. So it is going to create 3 memory location. That 3 memory location is going to point to 3 one-dimensional arrays. Those one-dimensional arrays can be of any. It can contain any number of values. It can be containing 3 values, 4 values, 5 values. It's up to the one-dimensional array how much it has to contain. Okay, so it's up to us, to declare that initially itself. If you don't know it, that's fine. We have to define only this array is going to contain 3 one-dimensional arrays. That is enough for defining purpose. So if you define like this, a is equal to new integer of 3 comma 3. I say it as 3 comma 3. Even though there is no comma there, we represent it as 3 comma 3. Okay, so this means basically contains, the first 3 means it is containing 3 one-dimensional arrays, and the second 3 means in that 3 one-dimensional arrays, each of the array is going to hold 3 elements in it. The next thing is, trying to create these arrays. Look at it. There are 3 one-dimensional arrays: A1, A2, and A3. A1 is a one-dimensional array which is containing 3 integers. A2 is one-dimensional array containing another 3 integers. A3 is containing another 3 integers. So 3 one-dimensional arrays. Here we are going to create a 2-dimensional array where I'm saying 2-dimensional array A is equals new int of 3 comma 3, which means it's going to contain 3 one-dimensional arrays, and each one-dimensional array is going to have 3 elements in it. So now if I want to say A of 0, the first element in the 2-dimensional array is going to be holding a 1-dimensional array, and the 1-dimensional array address is A1. Second element is going to hold a 1-dimensional array which is A2. Third is going to hold 1-dimensional array which is A3. So this is how it is going to be working. So A will be reserving 3 memory locations, and for each of the one-dimensional arrays 0, 1, and 2. So the 0 will be referring to a one-dimensional array, and this will be 1 will be representing to another one-dimensional array, and 2 will be representing another one-dimensional array. So this just going to hold the initial address of 0 is going to hold the initial address, which is the A1 reference it is going to hold. The 1 is going to hold the A2, which is the reference of the another one-dimensional array. So if you want to do just like the previous one, if you want to initialize all at one shot, you can do for the 2-dimensional array as well, where you will put curly braces, and each curly braces, you will have one curly braces to represent the 2-dimensional array. So that is going to contain 3 one-dimensional array, right? So it's going to put curly braces and then put the values, comma, curly braces, the next element, comma, the next element. So instead of giving 10, 11, 12, let's say 3 elements, 1, comma, 2, comma, 3, it's going to be one-dimensional array, comma, another one-dimensional array, comma, another one-dimensional array. Each one-dimensional array can have any number of elements that it wants to be. So that's about 2-dimensional arrays. We will move on to the accessing part of it. So what is this accessing is like, say if I want to access a 2-dimensional array, I'll give b of 0, 0, which means it is representing the 10 actually. So here the 0, 0 means you can think like it's a row 0 and a column 0. Okay, that's another easier way to represent it. So the another way is the first 0 corresponds to the first entry of the 2-dimensional array. In that first, which is pointing to, think about A1 here, and in that A1, which element you need to locate the first element, which is going to be the 10. That's how it looks like. So you can also represent row, 0 in that terms. If you see it, it's going to be the first row is going to be represented as 0, second row is 1, third row is 2. So if I want to access 10, I should say b of 0, 0. If I want to access 13, I should say b of 1, 1, because it is in the first row, first column actually. In fact, it is second row, second column, but in indexing wise, it is going to be first row, first column. And same is the case with 16. If I want to access 16, I will say b of 2, 2. Because it's row 0, row 1, row 2. It is in row 2 and column 2. And if I want to represent 12, I will say it's in the row 0 and column 2. So it's b of 0, 2. So this is a way to represent each and every element in the 2-dimensional arrays. You can increase these dimensions with 3 dimensions. It's going to be the same way, but it's going to be a little bit confusing. You have to put 3 brackets here and you have to define it. But we don't really do much coding in real time with 3-dimensional arrays. Like a normal, I'm saying about for people who works on graphics and other stuff, they do that. They do with 3-dimensional or even more than that. But in a normal scenario, we don't go beyond 2-dimensional arrays. So let's see some programming examples with arrays. Create one package for that. I'm going to name it as arrays. So the first one is max number. Okay, so this program we will try to find out a maximum number in a given array. So let's make an array, simple array with values. So integer array equals, I'm going to give some values, 2 5 7 3 2 or 3 6 4. So this is my array. So if you want to print this array, how do you do this? There are two ways to print this array. First thing is using the index, like int I is equal to 0, I less than a dot length. So this is a field that is present in the array object. Just like in a person object you have an age and name field. In the array object you are having the length field actually. So it's not going to have a bracket here. It's not a function, it's the field that is present in the array. So this gives you how many length the array is. So here it is, six numbers are there, so it's going to give 6 here. Then give I plus plus, and you can say system.out.println, and now you specify I wanted a of I, so it will be f0, f1, f2, f3, f5 till a of 5. It's not going to go 6. If you are printing 6, it is going to give you array index out of one exception. Let's save this and run this program. So as you see here, you get 2 5 7 3 6 4. Okay, there's another way to print this array. Instead of specifying the index, you can also do like in a for each syntax. So we call this as a for each syntax, and this we will learn more in the when we talk about collections, but just for representation purpose. So you can do like this as well. So here we are saying for each integer in array A, print the integer. So it's another syntax. So it also prints the array. It's a kind of easier syntax instead of doing this way. Okay, so before we now the intention of this program is to basically calculate the maximum number in the given array. So we know how to calculate it manually. So if I look at the array itself, I can say 7 is the maximum number, right? But think about it in a programmatic or in an algorithmic way. How do we arrive at that actually? In the manual effort, how we are performing this in manually. So we take, when we go through with our eyes, we said, we took the first element. Okay, this would be my maximum at this point of time. I take this and I compare with the next element and seeing, okay, 2 is greater than 5. So what I will have in my memory now is the maximum element is going to be 5 at this point of time. And you compare 5 with 7, and now you swap it because your maximum element is going to be 7 till this time. And then you check with 3. 3 is not greater than 7, so you are not going to update your memory location. Update your memory. It's going to be you are still going to keep 7 as your memory. And then with the 7 in mind, you will always compare with 6. 6 is not greater, 4 not greater. So the final memory that remains inside is your 7 actually, right? So that's how we are going to do it with the programming also. So we first, assume the first number as our maximum number, and if we get the assumptions negated, we are going to change the maximum number each and every time we check for it. So let's try to do that. So we will have the max number as our first number, which is AF0. AF0 represents the first number. So 2 will be our maximum number now. Then what I'm going to do is put a for loop and then say integer I equals, I want to start from 1 because 0 I already parsed it. I know 0 is my maximum number at this point of time. So I want to compare it with 5. I don't want to compare it with 2 again. So 0, I just wanted to have that way. So I less than a dot length. A dot length is going to give me 6. So why I'm not putting 6 and a dot length is because if I want to increase this, like say, I want to make it as 9, 5. So I can increase any number of values here, so I don't want to come and change this value again and again. So it's better to have it as code it as a.length. Okay, so I start with 1 and I go till the end of the array and increment this I value each time. Now what I'm going to do is I'm going to check first if maximum value, which is 2, is going to be greater than 5. How do you get 5? It is going to be a of 1. A of 1 is 5. So 2 greater than 5. If 2 is greater than 5, what I'm going to do? I'm going to basically swap it, right? So it should be other way around. It should be a of 1, a of I greater than max. So the current element is 5. If 5 is greater than my assumed element, then I'm going to swap my assumed element, right? So max equals a of I. So now my new max is going to be a of I, not the 2, not the a of 0. Now it is going to be a of 1 because a of 1 was greater than a of 0. So I'm just going to swap my max value, right? So like this, what you're going to do is, otherwise you're going to don't do anything. So finally, when you do, when you finish this loop, and if you try to print your max, you're going to get like the maximum value that is present in this array, which is going to be 9 here, because that is the maximum value. Okay. So that's about the single dimensional arrays. There are many programs you can do with the single dimensional arrays. You can do a many sorting algorithms like bubble sort, quick sort. All these things can be performed using this using the single dimensional arrays. But we will see one more example, which is going to be dealing with object array actually. So that helps you in understanding how we can produce some useful results, or how we can even create objects arrays first. So before we go for the object arrays, let's create an object first actually, and then put some methods and behaviors for that. Before we construct an array of the objects. So let's take a student example. Let's create a student array. So before that, we create a student object. So student object, what are the things the student object is going to contain? Let's say this will contain the roll number, private, and registration number, or registration number, and then private integer. Before integer, we'll put name. It will contain the name of the student, and then it's going to contain, let's say we are going to calculate the marks and the grade for the student. So I'm going to make it as private string. So we'll take 3 marks, math mark, and then we'll take science and English. Okay, so private science and then English. We copy this. Okay, so I got 3 marks for the student. And I would like to also maintain few more things, like I would like to maintain the student results here, right? So I wanted to maintain the student result. I want to maintain the student grade actually. So so for that, to calculate the grade, I may need the total and the percentage. So I want to maintain some more instance variable, so which is going to be private integer total. So as I'm assuming to be everything to be integers. I don't want to go with the double logic, so even if it is resulting in double, I want to convert it to integers for simplicity perspective. Okay, so we have a total. We have what else? We have percentage, and then grade and result. Okay, so we have total marks, and then we'll have percentage, then we will have grade, and grade will be more like a result. Basically, result is going to be string, not integer, so making it as string. Okay, He's having a result. The student is going to have almost all the things like and then the grade actually. Okay. There you go. Okay, so you can give some initial values for this, like the result can be made it as fail by default, and you can make it pass if he's meeting a condition, and grade can be mentioned as not applicable actually, like NA. Okay, so we have our instance variable. These are the student variables that he can have, and I'm going to create a constructor basically to accept all these values. Like the inputs of the student is going to be registration number, name. The student is going to provide registration number, name, math mark, science mark, and English mark. This is his input actually. And what I'm going to find out is the total and then the percentage and then the result and the grade. This is my output which I'm going to calculate from this input actually. Okay. So let's make a constructor for inputs alone, because we are not going to supply output. Output is going to be coming from the user, right? So source generate constructor using fields. So I don't want all, I just deselect all. I'm going with registration number, name, math mark, science mark, and English mark. So if you put the constructor, it's going to help you in creating the objects easily, but it's not mandatory. You can even do it with setter methods actually. Okay. So there you go. You have a student object which is going to take all these values, and then it's going to assign these values basically. I'm not going to update the private variables directly. Instead, I'm going through the constructor and trying to do this. Then I will need basically a method to calculate my result, grade, and all these things, right? So what I can do is I can write a method called calculate, and this method I don't need to really expose to the outside world. Nobody needs to know about that, how the calculations is done and stuff like that. So I can create the method as a private method, and this method is going to be named as calculate, and this calculate method is going to have first calculate the total. So total is equal to what? We have the math mark plus science mark plus the English mark. That is your total. Okay, we calculated the total, and hold on, some error. What's that error? Oh, you know what? This is my bad. Actually, it should be okay. It should probably string. It's a copy paste error. It should be integer. I'm sorry. Okay. Okay. So the next thing is I will create a constructor again so that it reflects these changes. Okay, so we got the total, and the percentage calculation is easy. It's just going to be total divided by the total number of subjects, which is going to be 3 in this case. So it's going to be total by 3. Now I have to calculate the result. How do I calculate the result? He needs to get passed in all the subjects, right? So I can create a variable, final variable, which is defining my pass mark. So I can say private static final int pass mark. Okay, pass mark is equals, I'm making it as 35. Okay, so here I'm making it as final int. That means it's going to be a constant, and it's a static. It's not going to create for every student object, because it's going to remain the same. So pass mark is going to be 35. So what I can do is I'm going to check each and every mark. So I'm going to check math mark is greater than pass mark. So I can even hard code it as 35, but if you want to change this in future, it is easy to change there instead of changing in all this logic actually. And then say science mark is also greater than 35, and then say English mark is also greater than 35, not 35 pass mark. So just replace this as well. Okay, so I should make it even better, greater than equal to, so that even 35 is a pass mark, right? So I'm just making it greater than equal to. Let me maximize the screen. Okay, so if all of this mark is greater than equal to, then I'm going to make the result as pass. Otherwise it remains in fail, because we initially assigned as fail here. Okay, so now I'm going to calculate the grade only if the result is pass. If he's failed in even one subject, I'm not going to calculate the grade. So how can I do that is, if result equal to, instead of putting double equals fail, I'm going to use dot equals. We will see what is this dot equals means in the later sessions of string, but assume I'm going to use this. As of now, it's just going to understand this a string is a class, and it's just going to have an equals method which compares the contents here. Okay, if result dot equals pass, then what I'm going to do is I'm going to check the percentage. Now if percentage is greater than or equal to 75, then I'm going to give him the distinction, grade is equal to distinction. Okay, else if is at least, if his grade, his percentage is going to be greater than 60, greater than or equal to 60, then I'm going to give him the grade as first grade actually. Otherwise I'm going to give him second grade. So only if he passes, he comes to this block. Otherwise, he will not even come to this block. So if he's failed, he's not going to get any grade actually. So that's how it is. And then yeah, we calculated the marks now. So we are done. So the calculate method is done. Now what we are going to do is, we have to have, if we want to retrieve what is the mark, what is the grade, what is the result. If I want to retrieve all these things, how do I retrieve it? There's no way, because these are all private variables, right? So what we need is, basically we need to get a getter method for all of these things. So you go to source, generate getter setter methods, and I don't need a setter method, I just need to get all these values by the outside classes. So I do select getters, let's say generate. So I'm going to get all the getter methods for all these fields. So anything I want, I can access it from any other class. Okay, save this file. So we have not still finished or tested this. So let's try to run another program, which is going to be student test. Okay, so the student test is now going to calculate few things. It is first going to calculate you know, it's going to first create a student array, and it's going to store a lot of students values here, the marks and the names and stuff like that. Okay, so it's going to create that, and then it's going to, once it creates a group of students, it's going to find out who got the highest marks in each subject section. And it can also calculate the number of students passed and number of students failed. So it's going to do two things. It's going to calculate number of students passed and failed, and it's going to calculate highest marks in each subject. Who got the highest mark in each subject? So we're going to calculate these two. Okay, let's let's first create the student array. So before creating the student array, we need to have the objects created, right? You need to have the student to create the student arrays. So let's create the first student. Student s1 equals new student of, we have a constructor, so it can take the roll number and then the name. Let's say the name is Joseph, and we go with 45, 67 and 45. Okay, So this is student 1, and we will create a similar students, like at least we'll create 4 students, 4 or 3 or 4 students, so that it gives some inputs for us. Okay, so I will name it as student S1, S2, S3 and S4. So this is going to be 102, side is going to be 102, 103 and 104. Okay, let me change the names and the marks as well. Keep it as Sandesh and 95, 67 and 85. And then we'll keep one more, change it to James, 65. Okay, let me make it as 77 and then 75. Okay, so the next thing, the last name, I'm going to keep it as Barb and then 25, 87, 65. Okay, so as you see here from your manual analysis, couple of students failed, not couple of students, at least I say like one student failed, which is Barb. She got 25 in the math, and the other 3 passed basically in all the subjects. So that's the story. But even though she failed, she got the highest mark in science, which is 87, and Sandesh is the one who got highest marks in the other subjects actually. So this is the output we wanted to achieve. So let's try whether we are able to achieve this output with our program. Yeah, you can add one more student for failure. So we can say, so that we get 2 students for failed students. So we'll name it as 105, call him Gordon, and he gets 75 marks. Let's make it failure, 28 and 78. Okay, so 2 failed students and 3 pass students. Okay, that gives a good amount of students here. So I created, I didn't create an array yet. I'm just creating 5 student objects. Now I'm going to create an array to hold these 5 objects. So the array, can name it as yes equals, you don't need to put, since you have created the array and all these values, I'm just going to make it like S1, S2, S3, S4, S5. You can do like this. If you wanted to create array, you can also do student of S equals new student of 5, and then say S of 0 equal to S1, S of 1 is equal to S2, like that also you can do it. But this is the easier way. Since we know we are going to hold only 5 students, I can create like this. But if you wanted to hold like 50 students and you want to read it from a file or something, the other option is the better option. Okay, now I need to hold some variables like max, math, who got the maximum mark in math, max and all these things, right? We already know how to calculate the maximum program, which we saw in the previous session. So let's try to do the same thing here. We assume the maximum mark as 0 initially for max. Maximum mark for science is 0, and we will have maximum mark for civics, or English, as 0. Okay, we assume this is the maximum marks. Now also we need to also do which student who got this, right? So I wanted to capture the student who got the maximum marks. So I'm going to hold the student object, student max math student. So I'm just holding the values. I'm not really, I don't know which one, is this, but I'm just saying, null for this now. I don't have any values. Just going to keep it as null. But once I iterate the students and find out the value, I'm going to assign that student actually. Okay, so let's do this. So I'm going to keep hold of max math student, max science student, and max English student. Okay. So I have all things ready. Now I just need to iterate the student array and then do this. But before we do all these things, we never invoked the calculate method itself, right? When I give this marks, it is not going to calculate it. We have to invoke s1.calculate so that the marks gets calculated and the results will be ready for us. So instead of using s1.calculate, s2.calculate, s3.calculate, manually asking the people to call it, we can do something else, and they cannot even call it because this is a private method actually, right? So we defined as a private method. Either we need to make it public and then ask them to call that method to get the marks calculated, or the other simpler way is, since they are using the constructor for creating the object, in the constructor itself you can call the calculate method. So the moment they create the object, it is going to invoke this method and it is going to calculate all these fields. The rest of the output fields is going to get calculated and kept it ready. So now you have all the information ready, like each of the student results and everything individually it is ready, but we are not working on individual items. We are working on the group items here, not the individual items. We wanted to calculate how much they got in, how many students passed, failed, like that, not the individual students, whether he passed or not actually. Okay, so that's our interest here. Okay, so now we go with for loop. You can use either syntax. I'm just going to use for each student. Let me make this as st and then create for each student s in student array st, for each student s in the array st. So you can do like this, or you can if you feel that is difficult, you can use a for int I is equal to 0 and I less than st dot length I plus plus, like that also you can define this array. So this is a shorter form for each student in the student array. I'm going to do it. The first student will come in the first s, second time it is going to replace by the second student, third time it is going to be replaced by the third student, like that. So now first thing what I need to check in this array is, I want to check whether the student mark is going to be each mark I'm going to check. So first I'm going to check whether the current mark of the student, which is s dot get math. Let's start with math. If his math mark, the current student's math mark is greater than the max mark, so max math is 0, but if the current student is greater than that max math, we are going to swap it. I'm going to assume now the max math is going to be the current student's mark, s dot get mark, right? Current student's mark, that is my maximum mark till now, and then the maximum student is going to be this student, whatever I have captured till now. This is the maximum guy till now. I'm just looking at only Joseph, and I'm just looking at his mark. So max mark, so 45. Initially I'm having the max mark as 0, and 0 is, 45 is greater than 0, so I'm just going to replace this max mark as 45. When I get to the next student, he is getting 95, so what I'm going to have, the max math will be 45, and this is greater than that, so I'm going to replace it with 95, and I'm going to store this student Sandesh as the top performing student for math. Okay, the same thing I'm going to do for all the other 3 subjects. So I'm just going to copy paste it, just going to replace this with science, and this also I need to, it's not math max math, science max, and here also. And here too. Okay, so it's all science. Now replace the same thing with English now. There you go. So we are done with all these thing. So we found out, at the end of the array, we will know who got the maximum marks, who got the maximum English, and all the stuff. So also we said we are going to calculate the number of students who passed and failed, right? So we have a counter for that. So do we have a counter? No, we didn't create a counter for that. So we need to create a counter for that. Like we need to have integer, say passed count equals 0, and then failed count equals 0. Initially no one passed, no one failed, but once you iterate a student, so once I iterate the array, I'm going to get the first student, and once I get the first student, I'm going to check whether he is pass or fail, and depending upon that, I'm going to increment the counter. So I'm going to check like if s dot get result equals to pass or not. So I'm going to say pass. If he's pass, instead of equals, I need to go and put dot equals. It's a better way to do it. I'm sorry. If s dot get result dot equals pass, then I'm going to increment the passed count, and all these are happening in the for loop. Okay. Else, if he's not passed, he's going to be failed. So I'm going to increment the fail count. That's it. So finally, I'm done with this for loop, which is going to calculate all my figures. Finally, I'm going to print them all. So how do I print them all? Just put all these in the sysout actually. So sysout, you can say who got maximum mark in the math. So you can say max math student. So I need to print the student information, right? So again, there is a catch. We didn't discuss this before, but we will be discussing quite in the next few sessions. So what I am going to do is I'm instead of, if I print a student, let me first show you, then we'll do it. So system.println max math student, and so I'm going to say max assigned student and max English student. That's it. So okay, why it's failing? So these are the students who got maximum marks. So, and then I'm going to planning to print the results as well, right? So we are going to say passed count and failed count. Okay, so all done. So we need to run this. So you see that the first three students, it's not giving me the proper values. What I expected is Sandesh, Barb, and Sandesh, but it's not going to print that. It's printing something like student at something. Okay, so which is not the one I expected. But what is going to happen is when I print a student, if I print an integer, it's going to print the value. But if when I print a student object, it's not going to print that object. It's going to print, what is going to happen here is it is going to go to the so you basically, when you say if you print any object, it is going to invoke the toString method on that object. Okay, it's going to print like this. It is going to replace that with toString. So this .toString method should be present in this student object, but we don't have a toString method here. We didn't put any toString method here. So what is going to happen? How we are able to call it is because every class is a subclass of object class, right? So whether you get it or not, whether you put it or not, it is going to extend from the object class. This is how it is going to be, right? Whether you put this statement or not, it's going to be like doing like this. Every class is extending from the object class. If it is not extending from another class, right? So now if you go to this object class, if you ever see this object class declaration, there is a toString method in this object class, and that is going to be just printing the class name with some references there actually. Okay, so it's not going to print you the it's not that is the one. What happens here is when you print this one, it is calling the toString method of the object class, and that is printing in this way. It is just printing the class name and then put at symbol and printing some characters actually. So in order to print a meaningful information, what you have to do is you have to override this toString method. So remember what we talked about overriding. We don't like the parent class implementation. We want to give our own implementation. So I don't like the object class implementation of printing this object. I want to print it in my own way. So Java Eclipse provides a facility for that. Go to source, go to generate toString method, and here you can specify what are all the fields you need to include in the toString method. I want all the fields, so I'm just going to say select all the fields and then say generate. So what is going to happen is it's just going to return a string, and that string is printing all the information about the student here. So just save it. Now go to student test, and then you don't need to put toString. If you put it also, there's no problem. So here .toString is automatically called here, whether you put it or not. So now run this program. So you get now a good amount of data. So see the student number 102 Sandesh has got the highest marks in maths and the English, but student 104 got the maximum mark in the science actually, which is 87. And then the number of students failed is 3, sorry, passed is 3 and failed is 2 here. So that that is nothing but you can define an object array, single dimensional object array, and work on deriving the statistics with that. Okay, let's move on to the next one, which is the two-dimensional arrays. It's a bit longer session, I know, but that I'll make it. That's the final thing. We'll do a simple example with two-dimensional arrays. So I will use matrix addition. So this is okay. So what are we trying to do here is, let me put it first, and then we'll talk about it. So I'm going to have two arrays, two-dimensional arrays. One two-dimensional array is going to have like this one, let's say 1 1 1 1. Okay, let me put it, comment here. I'm having 1 1 1 1 2 3, and then 1 3 1 2 4, or 1 2 4. Okay, this is my first array. My second array will be 2 2 2. Sorry. Oops. 2 2 2, and then it's going to be 3 3 3, and then it's going to be 4 4 4. So if I add these two things, what I'm going to get is it's going to be adding this one with this 2. It's going to be resulting in 3. So the first one will be 3 3 3, because we are adding each 1 plus 2 1 plus 2 1 plus 2. The second one will result in 1 plus 3 is going to be 4, and then 2 plus 3 is going to be 5, and then what else? 3 plus 3 is going to be 6. Right? So we get 4 5 6 here. Next thing is going to be 5. 1 plus 4 is 5, and then 4 plus 2 is 6, and 8. So this is what I'm expecting as the output actually. So we are doing a two-dimensional array. I'm having a row and a column actually. So this is nothing but row 0, right? This is nothing but row 0. Okay, nothing but row 0, and then this is row 1. And this is row 2 based on the array indices. And we'll also have a column which is going to be, this is your zeroth column, and this is your first column, and this is your second column. Okay, we call this as a array A. This is the array A, and this is array B, and this is array C. So we'll have repeated this one here. Okay, so we have the row and we have the column here. So all that we need to do is, we need to construct this array and perform a matrix addition. Let's see how we are going to do it. Okay, so first array, integer array. So how do you do this? We'll say two-dimensional array. First array is A equals, and I know the values, so I'm going to put the values right away. So I know this is a two-dimensional array, so it's a array of arrays, which is array of one-dimensional arrays, right? So first array value will be like this, comma, second array, comma, third array. What is the first array values? We know it, 1 comma 1 comma 1 comma 1 comma 1, and 1 comma 2 comma 3, and what is that, 1 comma 2 comma 4. So these are the arrays. Okay, second array is going to be very similar. We are going to put it, name it as B. So the second array it is, let me make it big. Okay, so second array, so the values will be slightly changing here, 2 2 2 3 3 3 and 4 4 4. Okay, so 2 2 2 3 3 3 and 4 4 4. Okay, this is our second array. So now we are going to calculate the third array, which is not going something we are going to define it, so we are going to calculate it. So integer array, the third array is going to be named as C, and this array is going to be created by us. So how much space we have to give? We have to give 3 rows and 3 columns. So basically it is going to be a two-dimensional arrays, which is going to have 3 elements in it, and each of these 3 elements is pointing to one-dimensional arrays. That is the meaning of this. So I have declared and created the array here. Now we have to put the values into this array. How do we do this? We have to first iterate the first array. For iterating the rows, I'm going to have for int I is equal to 0, I less than a dot length, and I plus plus. So this is for the first array, and then I do the same thing for the second array, like the columns. First is the rows, the second is for the column. Okay, let's do this. Okay, so this I will keep it as J instead of I, so it's an inner loop. So I should say a of I dot length here. Okay, that's a better way to represent. Okay, so this can be any numbers, so it's better to have like this, but for simplicity, if you don't understand this, let's keep it as less than 3 and less than 3. So that's easier to understand. So I have a 3 cross 3. So this is going to be representing the rows, and this is going to be representing the columns. You can even keep it like R and C. R stands for row and this is for columns. So let's keep it as R and C. Okay, so we are good. So integer. Oh, you know what? I have already a C here. So let me take it. Keep it as. Result. Okay, so now it's a simple calculation what you are going to do. So if you want to get this element, what you are doing is you are taking the 0 comma 0 of A and taking the 0 comma 0 of B and trying to add that. So A of 0 comma 0 plus B of 0 comma 0 will result in C of 0 comma 0, correct? So that's the one we are going to do it here. So C of R and row and column equals A of R and column plus B of R and column. So that's it. So when you do this, what's going to happen is, and instead of C, I will make it as a result of Rn column equal to. So first what will happen, it is going to get 0 comma 0, R of C result of 0 comma 0 equal to A of 0 comma 0 plus B of 0 comma 0, and then this loop will get 1 and this loop will get 2. So what is going to happen, it's going to be for the same 0th row, it is going to calculate for 1, calculate for 2. Then what happens, this inner loop will be completed, the outer loop will get executed. So this will become 1 now. So for the first row, it is going to calculate the 0th value, first value, second value. It's going to take this value, and calculate this value. Then it goes to the outer loop, which is the third loop, which will become 2. For 2, it is going to repeat for 0, 1 and 2. That way you calculate all these elements of the result. Okay. Now once you calculate it, you have to print it. So for printing it, you can again write these 2 for loops and then print it. That is one way. Otherwise you can use the same for loop whatever you have done it to print it as well. So to print, what you will do, you can simply say system.out.println. Once you have calculated it, you are just trying to print them. So sorry. So print result of C and R. Okay, that's it. So once you calculate, you are printing it now, but the problem is, let's run this and then see, and then we'll adjust it a little bit. So you're getting printed in this format actually, which is not the preferred way, right? So we should be adjusting it. Sorry. So how do we do this? How do we print this? So instead of println, you can give print here, and then okay, it should be, I'm sorry, it should be R comma C here. I put C comma R, I'm sorry. So it should be like what is that? Plus you need to put a tab. Okay, so which is just going to print it, which is going to leave a space after printing it. And for each once you print one row, you need to leave a line so that the next rows comes in the next line, right? So you put a slash n here. That's it. So if you this will print one row, and then in the outer for loop it goes to the second row when it does the iteration. That time you are going to leave a line here. So now you will get it in a matrix format. Save this, so you get 3, 3, 3, 4, 5, 6, 5, 6, 8. Whatever our desired output, we are able to achieve it here. That's all about your two-dimensional arrays, and you can use this for doing matrix multiplication, finding determinant. So all this is going to be the advanced topics in two-dimensional arrays.